Lucy. Alexa. No. Kiana, yes. Alex, yes. Jimena. No. Jennifer. No. Brianna. No. Mariana, yes. Christian, yes. Ethan, yes. Kevin, yes. Helen, yes. Oh, Zoe.
You go there every day, Tuesday, Wednesday, Thursday. Unless you go there, and it'll help you, trust me.
All right. All right, log in, ladies and gentlemen, to your computer so I can send you a pair deck so we can review for your test tomorrow, ladies and gentlemen. So get logged in. Here is the pair deck code. QAQVQS. Man, that's a lot of Qs. They cheated. They used quick twice.
Mr. Brent.
Yes.
Bought my prom ticket. And this is what the back of the prom ticket says.
Prom is better than due date. No, I'm always just. Oh, my Chromebook died. Womp womp.
Okay. Obviously, they have a new sponsor for prom this year.
Yeah. What was last year?
Prom sponsors?
Apparently.
Don't ask me.
Prom sponsor?
So,
Imagine going to prom.
You're not going?
imagine going to. You don't have to imagine. You can go. It's okay. All right.
Me and my best friend are going to go.
Okay.
Mr. Brent,
Chris, Ethan, come on. Get your stuff out. Put your phone in your headphones away. Get your computer out. Get logged in. Nobody's logged in yet, so.
yeah, because we can't see.
QAQVQS. What are you talking about? It's right there. My gosh. What else do you guys need?
Okay, that's a lot of Q's.
That is a lot of Q's. Yes. And it's about time.
I feel like that's rude.
You feel like that's rude. Then it's probably not if you only feel like it's rude. I could probably do better at being rude.
My feeling is hurt.
Your one feeling is hurt. Sorry about that. You said my feeling is hurt. So that means you only have one.
Faith, quit while you're ahead.
Yep. And you're not actually even ahead. So just quit.
Or quit while you're behind.
There you go. There you go.
I don't give up.
Look at there. 10 people logged in. That's awesome. That's awesome. There's 13 of you in class, but 10 of you are logged in. So that's good. Good.
I don't know why my Chromebook ain't turning on.
Maybe it's not charged.
I'm charging it now.
Maybe use an actual cord instead of a block.
As Mr. Brent would say, maybe she should have charged it last night.
Thank you, Jaslyn. Thank you. And now no one could say that because you could say, as Jaslyn says, you should have charged it last
My
night.
computer's at 100%.
Cool.
Victoria, respectfully. Who asked?
I did. Victoria, what percent is your computer at?
99 now.
Oh, bro.
All right. The plan for today, ladies and gentlemen, is as follows. We are going to get you ready for your quiz or your test tomorrow, which means that we're going to review that mini lab that you did the other day since you turned it in and I returned it to you. We're going to review the activity we were doing yesterday, the worksheet. We're going to review the worksheet that was due on Friday. And then I'm going to give you some time after we go through the study guide to work on Quizlets and the study guide to get ready for tomorrow's test. Tomorrow will mark the halfway point, ladies and gentlemen, through this trimester. And also, they haven't sent it out yet, but I would imagine they will be sending out the notice very soon that I have to put grades on a report card for you, your progress grades. So for those of you who are involved in spring activities, it's an important thing that you have passing grades for that. Also, ladies and gentlemen, again, set yourself up well for the last part of the year. When things get crazy at the end of the year, I know sometimes you guys forget to do things like charge your computer, study, do homework, things like that. So make it so that your grade is as high as it can be before you get into that time of year where you may find it harder to do things because the weather is nicer outside. Okay? So keep those things in mind, ladies and gentlemen. All lefty, here's our first question today for our pair deck. Predict what will happen to the variable in the question given the following information. So, if you look, ladies and gentlemen, here are pressure, volume, and temperature at the beginning. Here are the new pressure and the new temperature. The volume, ladies and gentlemen, is what you're predicting. So, is the volume going to increase? Is the volume going to decrease? Or is the volume going to be unknown? Now, to help you out, because we're going to be doing a few of these today, here you go. Here's some scratch paper for you, ladies and gentlemen, so that you can write on there what is going on as far as what's volume doing, what's pressure doing. Because remember, these two things will have an impact on the pressure, on the volume. Since you're changing two things, they may both say go up, they may both say go down, or one may say go up and one may say go down. That's what you have to figure out, ladies and gentlemen. By the way, what you're looking at right now is a bunch of the questions on the test that will be exactly like this tomorrow. Now, if you do not have it on your periodic table, ladies and gentlemen, I would either have your slide open that has the summary of the gas laws on it, or I would have your your open to the master. Variables for Boyle's law, Ethan. No, the one in back, sorry. And? Good. Pressure and volume, type of relationship, Ethan Babick.
Direct.
Boyle's law?
Boyle's law?
Oh, inverse.
The very first one we did?
Inverse.
Inverse?
Yeah.
Boyle's law? You're sure?
Yes.
Well, you were sure about direct just a minute ago. Which one are you sure of?
Inverse. I'm unsure about direct. I'm sure about inverse.
Inverse. So please remember, if you're talking about what is happening to volume here, according to pressure, it will be an inverse relationship. Charles' law. What are the variables, Lucy?
Volume and temperature.
Volume and temperature. Helen, what kind of relationship? Inverse or direct? Nope, not for Charles. Direct. Again, ladies and gentlemen, you have no chance of getting, well, I suppose you do have a chance, 50-50, of getting the question correct if you don't know what's going on in the relationships. All right. So, Guy-Lussac's law. Faith. Pressure and temperature. Mariana, the type of relationship. Direct. Okay? I don't think it's on any of these, ladies and gentlemen, but Avogadro's.
Volume and
Hang on. I always get his name confused with the O and the A in here. It's O first and then it's A. So I really have to think about it. Okay. Who was giving me?
me.
Victoria?
Volume and amount of gas, so N.
Volume and N, what kind of relationship is this?
It'll be direct.
This will be a direct as well. Okay?
Yeah,
So
because the only one that is
inverse is Boyle's. Otherwise, all of them are direct. Okay? Now remember, combined gas laws, it is part of each. It involves each and every one of, or each of these three gas laws. It does not involve Avogadro's. Okay? Does not involve Avogadro's. All right? So, ladies and gentlemen, what is our pressure doing here? Christian, what's our pressure doing here?
Going up.
Going up. What will pressure going up cause our volume to do? Which? Go with it. Say it. It'll decrease. Pressure should be causing volume to decrease. What is happening to temperature here? Constant. So can temperature affect the volume? So what has to happen to volume in this problem? So someone's at the door for this problem? What? Hello, Alexa. Good morning.
Morning.
So what is going to happen to volume here? It has to go down. There's only one variable affecting it, ladies and gentlemen, and that variable is telling it to decrease, so it has to go down. Questions? All right, so now you've got these changes, ladies and gentlemen. Now you've got these changes. What's happening there, and what's that going to cause our, in this case, temperature to do? Okay? So take a look at what's happening to pressure. Take a look at what's happening to volume. See how they're changing. Here are your gas laws that tell you how they affect temperature and which ones affect temperature. This will not take up much space on your periodic table, ladies and gentlemen, or on your solubility chart. There's a lot of room on there. If you need a new one for this week's quiz or this week's test, please grab a different one. I'm okay with that.
What is the solubility chart? This one?
That is the solubility chart. Yes. Wait.
The solubility chart is the other sheet of paper.
Let me see the back side of that one. Yeah, the solubility is this other one. I had given you this one, your periodic table.
Wait, were you allowed to use both of them?
And I had given you this one. Only all year long.
Oh,
You're allowed to use both of these.
Periodic table.
Nope, you're allowed to use both.
Oh.
Okay? You're allowed to use both. Okay. I need a few more responses, please, ladies and gentlemen. Okay. A lot on increase, one on decrease. Someone said unable to predict. All right. Well, pressure is not changing here. Kevin, which gas law are we going to use to determine what happens to temperature? Which gas law? We use Charles because volume is changing, temperature is changing. What's volume doing here, Kevin? Okay, so what's going to happen to temperature? Temperature will also increase because they are in a direct relationship. Okay? So again, if only one variable, let me try this again. If one of our variables is held constant, we will for sure know what happens to the other one based on how one changes. If it is one of these three laws, actually these four, you will definitely be able to tell what direction the variable is going. The only time we cannot tell is if it is combined gas laws and if they are going in different directions. All right, so here we go, ladies and gentlemen. Given those new conditions, the pressure, the volume, and the temperature before, again, looking for a temperature. By the way, temperature, doesn't matter if it's in Celsius or Kelvin. If the temperature is going to go up, it goes up in Kelvin. If the temperature is going to go up, it goes up in Celsius. Either way. If it's going to go down, it would go down in Kelvin. If it's going to go down, it would go down in Celsius. So the unit there does not matter. Now, remember, these need to be in the same units to compare them, but Christopher, what's happening to pressure here?
Pressure is decreasing.
What's happening to volume?
Constant.
Okay, so since volume is constant, which gas law are we going to use? We're going to use Gay-Lussac's. Pressure did what again? I'm sorry, Christopher.
Decreases.
So what does temperature got to do?
Decreases.
Temperature also has to decrease, ladies and gentlemen. Temperature also has to decrease. Okay? Questions? All right. Now, what do you notice about the variables here? Okay, but I'm not worried about a decimal. There, 3 out of 5 or 4 out of 5 happen to be a decimal. What makes this different than the last few problems we've been doing?
The volume is missing. The temperature and pressure both have different.
Okay, that was what I was going for. Thank you. We are solving for volume in this one. The last few we've been doing temperature. But the important thing here is pressure is changing and now temperature is changing. Now you've got 2 factors that are going to affect volume. So now, again, on your piece of scratch paper, you may want to say, okay, what's happening to pressure? What would that cause volume to do? Go up or down? What's happening to temperature? What would that cause volume to do? If you can keep it straight in your head, great. Awesome. Incredible. I don't know that I could keep it straight in my head. Good morning. This is the worksheet we did yesterday. We'll be going over it later. All right. Okay, Anna, what's happening to pressure here? Pressure is increasing. What's that going to cause volume to do, Kiana? If pressure increases, what would that cause volume to do? Decrease. Alex, what's happening to temperature here? Going up. What would that cause volume to do, Alex? Go up as well. Those are in a direct relationship. These are in an inverse. So, ladies and gentlemen, what ultimately happens to our volume here? Yeah, we are unable to predict. We can't tell. We can't tell because one variable is saying going up, one variable is saying going down. We just can't tell. So our best answer is we're unable to predict or we are unable to tell. Okay, here we go. Here's your changes, ladies and gentlemen. Let's see your choices, ladies and gentlemen. I'm interested to find out on here. We're a little all over the place. All right, well, let's start out with this, ladies and gentlemen. What is volume doing here? What is volume doing in this problem, Alexa? Volume stays the same. That means it cannot have an effect on pressure. Okay? What is temperature doing here, Ethan?
Temperature
is
decreasing.
What?
Decreasing.
Decreasing. How do you know?
Because when we're going from Kelvin to Celsius, it's subtracting 273.
Okay, so let's take this number and subtract 273 from it. What does that equal?
0.
What's temperature doing? Really?
The same.
Oh, staying the same.
Yeah.
So what's pressure going to do here?
Stay the same.
Pressure is going to stay the same. There were no changes here. Pressure is going to stay the same. It does not change. Okay? Ethan, you did everything right. Minus 273. But 0 to 0, no change. Okay? No change. Got to be careful. But you got to put these in the same unit. You could have converted 0 degrees Celsius to Kelvin by adding 273 to it. You still would have gotten 273. There still would have been no temperature change. All right, here you go. Here's another one, ladies and gentlemen. This one, there will be something changing. Or there are things changing. So, figure out what happens to volume. What would that do to pressure? Figure out what happens to temperature. What would that do to pressure? Well, we're again kind of all over the place. So, all right, let's see if we can figure this out. All right, what is happening to the volume here, Helen? Okay, volume is increasing. What would that cause pressure to do, Helen, if volume increases? Volume or pressure would decrease if the volume were increasing. All right, what is happening to our temperature here, Jaslyn? Decrease, thank you. I'm sorry, if you said it, I didn't hear you, Jaslyn. My bad. So if temperature is decreasing, what will that cause pressure to do, Jaslyn? Decrease. So what has to happen to our pressure in this problem, ladies and gentlemen? Has to decrease. Has to decrease. It's the only way that it can go. Okay? Only way it can go, ladies and gentlemen. All right. Here we go. All right. What is happening to pressure here, Jennifer? What is happening to our pressure here? Decrease. What is happening to our temperature here, Kevin? Increase. Figure out what happens to volume, ladies and gentlemen. Figure out what happens to volume. I can't decide if that's a blue or a purple there by the for the pressure. I think it's closer to my purple.
It looks purple and on our screen.
On your screen, it looks blue. It was supposed to be blue, but up there it does look purple. They need to give me one of those big screen touch TVs, you know, the 85 inchers.
Oh, and like
That would be awesome.
swing?
What? Yeah, like those math people who don't even need it. They get it. I don't understand. Math people are used to chalk and chalkboards. That's what they should have.
I'm everything.
What's the matter?
I
So.
want chalkboards. I feel like those are so fun.
Chalkboards?
Yeah.
Fun? Oh, God, no.
I love
hated
chalkboards.
chalkboards. So messy.
A new chalkboard? Good. An old chalkboard? Ugh.
Yeah.
But then you got chalk all over the place. And yeah.
I'd much rather.
No, it's that. Become a teacher. Get a chalkboard. See how much you like it.
Okay.
A whiteboard is so much better.
I like
A smart board is better yet.
Well, yes, but
So, yes.
You can only get
we
what
don't
you
all
get.
have those.
Mr.
Yes,
Brown.
but I'm special. I deserve more. What?
Oh.
But
That's aggressive. You should have a chalkboard and a whiteboard and a smartboard.
there's not room.
Yes, there is.
There
There's
literally
really
is
a-
not room.
We can
There's
make
gigantic
room.
poster up here. Like that's why you had to put it on the ceiling.
We can make room.
What are you gonna do? Take out my fume hood?
Yes.
Great idea. Okay, well, good. At least we got two different choices here. We're unable to predict and it increases. All right. Here's the thing, ladies and gentlemen. If this goes down, what does that cause volume to do? Up. If that goes up, what does that cause volume to do? Up. That means it increases, ladies and gentlemen. It increases. That is your answer. All right, our last one this morning, ladies and gentlemen. Okay. What is happening to pressure and volume here that changes the temperature? What's happening to pressure here? Go for it, Alex. Alex. Alex, good morning. How we doing? I know, I'm sorry. I'm moving a little slow this morning. What's happening to pressure here, Alex? Going down. Good. What is happening to the volume here? What's happening to the volume here? Go for it, Christopher. All right. If this increases, what will that do to temperature, Christopher? Yes. All right. If the pressure goes down, what will that do to the temperature, Victoria?
You said what? Sorry.
If the pressure goes down, what will that do to the temperature?
Go down.
All right, so what's our final answer for our final problem on our final day of this stuff? What? Unable to predict. Good. Questions, ladies and gentlemen? All right. Excellent. Wonderful. Amazing, ladies and gentlemen. Okay. That's it for the pair deck. All right. On Friday of last week, we did the mini lab. The first station where we took the candle, burned it in the water, put the cover over it. What happened when you put the cover, the beaker over the candle? Go. Okay, but still, tell me what happened.
The water.
Well, the candle did what? No. Just tell me what happened to the candle. It eventually did what? Burned out. And then what happened inside the beaker? The water rose. The water rose. So for sure we know that the volume did what? What? How? Remember, it's the volume of the gas. Why did the water go up inside the beaker? Because the volume of the gas did what? Went down. Volume of the gas went down, the water went up. What caused that? What caused that was the amount of gas changed. We used up the oxygen in there. We got rid of it. That's why the candle went out. The volume went down. That was Avogadro's law, and it was direct. Next station had the boiling water bath, the hot water bath, and the beaker with the balloon on it, the flask. You put it in the hot water, what happened to the balloon? Inflated. You put it in the ice bath, it what? We were changing temperature, and what else changed because of it? If the balloon inflated and deflated, what's changing? No. The amount of gas was constant because it was sealed. The balloon and the beaker couldn't allow any more gas in. But what did change was the volume of the gas, how much space it took up. Thus, volume and temperature, direct relationship, Charles' law for station number 2. Station number 3 had the marshmallow in the syringe. Actually, you had done that earlier. You had done Boyle's law. What did you change about the syringe? The what? By pushing it in and pulling it out, what did you change? You changed the volume. What adjusted because of that? Pressure. What did more pressure do to the marshmallow? Compressed it. When you pulled the syringe out and made less pressure by making more volume, what happened to the marshmallow? It got bigger. It got bigger. That was Boyle's law, ladies and gentlemen, an inverse relationship. The last station, you took and you pumped up the bottle. What were you actually doing to the bottle? When you pumped it up, what were you actually doing? No, the bottle did not change its size. What? Actually, you were adding more gas. You were adding more gas. Now, more gas did cause the pressure to go up. Absolutely. Okay? Now, the reason we can't say the amount of gas changed is because then the only other thing that could have changed would have been the volume of the container, but it didn't. The container didn't get any bigger. Excuse me. So pumping it up increased the pressure. What else changed? The temperature. Temperature went up. Direct relationship, Gay-Lussac's law, ladies and gentlemen. That was the 4 that we did in the lab. Questions? Now, when you go back and look at your lab, ladies and gentlemen, when I graded it, you had to get the changes correct. Some of you flipped the independent and the dependent variable. I only took off 1 point for that. But if you got the variables wrong, but then you told me the right gas law for those variables and the right kind of relationship that you had gotten, I gave you credit for those. So just because you got the ones wrong at the top, if that continued throughout, I didn't mark it all wrong. So if the first one, instead of Avogadro's, you gave me Charles' law, but you gave me the correct relationship and which way the variables were going, I still gave you credit for that. Okay? So I still gave you credit for that. Good, 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 good. All right. This was the worksheet that we gave you the other day, ladies and gentlemen, last week, Friday. Now, again, this table has all of the relationships on it. I've given this to you. It's the last 2 slides in our notes. Again, I would have this information on your periodic table or somewhere for the test tomorrow. Unless you can remember, Boyle's law is an inverse relationship. Charles, Avogadro's, and Gay-Lussac's are all direct. I would write it down somewhere for yourself because it will be very helpful to you. Okay? It will be very helpful to you. But again, that is your choice. Okay? I have asked you this question multiple times on your lab, on this review. I'm almost guessing it'll be on the study guide today, and I'm almost guaranteeing you it'll be on your test tomorrow. Why must temperature calculations be in the unit of Kelvin when you are doing gas law problems? Why? Kelvin is an absolute scale. It has no negative numbers, ladies and gentlemen. None. And therefore, ladies and gentlemen, we get a constant when we use temperature in Kelvin in both of these calculations. We don't get a constant when we did pressure and temperature with degrees Celsius. Matter of fact, we had 2 numbers that were positive and 2 numbers that were negative. You only get a constant when you do your calculations in Kelvin. Okay? It is an absolute scale, meaning no negative numbers. All right. Number 2 here, ladies and gentlemen. What variable is changing in the equation? We've got 2 volumes. That's changing. What is it doing? 95 to 70, it is decreasing. What variable are you solving for? At what pressure would 3 words, 4 words tell you which one you're solving for pressure? If we're dealing with volume and pressure, it's Boyle's law, which means that if this one is decreasing, this one would have to increase because they are in an inverse relationship. Questions, ladies and gentlemen? Wonderful. Okay, so again, here we've got a problem. What variable is changing? I'm going from 560 to 400 milliliters. That means volume is changing and it's decreasing. There's a temperature given, and what would happen to the temperature? So I'm solving for temperature. That's Charles' law, ladies and gentlemen, because of volume and temperature. And if one is going down, the other is going down because they're in a direct relationship. That's what you should have gotten for number 3. Number 4, ladies and gentlemen. Gas has that pressure at that temperature. If the temperature changes to this, okay, so temperature is increasing. What would happen to the pressure? Pressure is what I'm solving for. Gay-Lussac's law relates pressure and temperature. They're in a direct relationship, so if one increases, so does the other. Stop me if you have questions. Number 5. We've got 2 temperatures here, 0 and 30 degrees Celsius, so temperature is increasing. What will happen to the volume? So we're solving for volume. Charles' law for volume and temp, increasing, because if one increases, the other increases. Questions? So this problem, we've got a pressure of 98.6 kPa and 121. So pressure is changing. It is increasing. What would happen to the temperature? Temperature is what we're solving for. Pressure and temperature are Gay-Lussac's law. Gay-Lussac's law is a direct relationship. So if one is increasing, so is the other. Questions? Okay. So, again, our volume, 95 to 70. Volume is changing and it is decreasing. At what pressure? So pressure is what we're solving for. Boyle's law relates pressure and volume because they're inverse. This one is decreasing. This one will increase. Questions? All right. We've got a pressure here, 28.6. Pressure here, 18.6. Pressure is changing and it is decreasing. At what volume? Volume is what we're looking for. Pressure and volume are Boyle's law. One decreases, the other increases. So your volume would have to go up in this case, ladies and gentlemen. Questions? All right, combined gas laws now. How is the volume changing in this equation? So volume is going from 3.65 to 2.54. It is decreasing. What effect would that change have on the pressure, which is what we're solving for here? What will happen to the pressure? Volume decreases, pressure increases. How is temperature changing in this question? Temperature is going from 45.3 to 80.3. That is an increase. If temperature increases, that will cause pressure to increase. So what's going to happen? Pressure increases because of Boyle's law. Both changes are making it increase. That's how we know. Questions? Number 10. How is pressure changing in the question? Pressure is going down because we're going from 145 to 105. What will that make volume do? Because what will happen to the volume of this gas? It will make it increase. The temperature, ladies and gentlemen, is going from 16.2 to 48.6. It is increasing. That will cause volume to increase. Since both of these are causing volume to increase, the only choice it has is to increase. And combined gas laws does this, but both changes are making it increase. That's the reason we could say it is increasing. By the way, do not get hung up here, okay, on the fact that the pressure is decreasing and the temperature is increasing. People are like, well, I thought pressure and temperature were in a direct relationship. They are when they're the only two variables. But when you involve a third variable, you can make pressure not have to necessarily go in the same direction that temperature does. But only because there's a third variable involved. Thank you. All right. What is happening to volume in this problem? Volume is going down. What effect would that have on temperature? Because what will happen to the temperature of the gas? That will decrease because they are in a direct relationship. Pressure in this problem is increasing. What will that have on a temperature? It will make it increase. So you cannot tell. Why? Because the changes go in opposite directions, ladies and gentlemen. Those are your three options. They both go up, they both go down, or they go in opposite directions. That is it for that worksheet. Questions, ladies and gentlemen? All right, then the last thing that I would like to go over with you before I give you your study guide and give you some time to work on it is the worksheet that we were doing yesterday. So again, ladies and gentlemen, take that out. Most of you, or you should have finished it. If not, I guess you're going to be finishing it right now. Doesn't matter. I'm not collecting it, ladies and gentlemen. So, okay. So problem number 2, ladies and gentlemen, pressure remains constant. That means pressure can have no effect on our outcome. So I'm crossing it off.
Which one are you on?
I'm on number 2. What volume? So we're solving for volume, ladies and gentlemen. That's the one you should have highlighted that you are solving for. Now, what is happening to temperature in this problem? We're going from negative 20 to 0, so temperature is going up. So what will temperature going up cause volume to do? It will go up. So what happens to volume? It increases. Why? Charles' law. Okay? It increases because of Charles' law. Questions, ladies and gentlemen? If you are asked on a test, on a problem, to tell what happens, and you abbreviate increase, INC, I'm fine with that. If you abbreviate pressure, capital P, if you abbreviate volume, capital V, if you change temperature to a capital T, those are what we have been using all along. I am fine with those, ladies and gentlemen. So again, I want you to be brief if you are writing up an answer on your test. So you could say pressure increase, volume decrease. What does that do to temperature? Things like that, okay? So you can use P and V for those. All right, number 3. Now, with number 3, we've got a couple changes that are going on here. First of all, what will the volume be? That means we are solving for volume here, ladies and gentlemen. That's what we're trying to find. So if that's what we're trying to find, there has to be a change in pressure. Pressure is going down, ladies and gentlemen. What will that cause volume to do? It will cause volume to go up because they are in an inverse relationship. What is temperature doing in this problem, ladies and gentlemen? Temperature is going up. So what will that cause volume to do? Cause volume to want to increase. So what is volume going to do here? It's going to increase. Both variables are telling it to do that. What gas law? Combined. Questions? So number 4, ladies and gentlemen, what temperature? So we are looking to find a temperature. But at the very end, it says the volume does not change. That means, ladies and gentlemen, this cannot have any effect. So we can cross it off. Now, we know that the pressure is changing. We know the pressure is going down from 98.5 to 103.5 means pressure is going up. My bad, ladies and gentlemen. So if pressure goes up, that means temperature is going to go up. That is Gay-Lussac's law, ladies and gentlemen, and the only thing that pressure can do here is increase or go up. Okay? As soon as you cross off one and make it into a Boyle's, Charles, Gay-Lussac's, or Avogadro's law, you should be able to tell what is happening. The only time we can't is if we are using combined gas laws. All right, the last one, ladies and gentlemen. Now, we are solving for a pressure. Volume in this case, ladies and gentlemen, is going down. Volume is going down. What will that cause pressure to do? Go up. Temperature, ladies and gentlemen, we needed to put them into the same unit. When we put temperature into the same unit, we actually get a temperature of 285, which means temperature is not changing. So because of that, ladies and gentlemen, volume is the only thing affecting pressure, and that is Boyle's law. And in this case, it means that pressure is going to increase. Questions? Any questions at all on the sheet?
When is the only time that it'll decrease then? Because on here, most of them only increase.
It could go either way. It really could. I don't know if, again, when I wrote these problems, I don't know why, but yes, a lot of them work out to be increasing. They don't have to be that way. What has to happen is the relationships, the laws have to hold. So on this one, I could have said temperature decreases, which would have caused pressure to, or I could have said pressure decrease, which would have caused temperature to decrease. I don't know why. I just happened to do it where they increase quite a bit. Okay? So there's no, it's not like, yes, this is what happens most of the time. It's just that's what's happening here. Yes, Faith. Why is number 5 increasing? Because if we convert 12 degrees Celsius to Kelvin, that makes it 285. That means that one is not changing. Okay? Volume went down. Volume went from 5.25 to 1.21. Volume and pressure are in an inverse relationship. That's Boyle's law. So since volume goes down, pressure has to go up. Okay? Good. Oh, what? No, that's fine. That's fine. It becomes easy to confuse these if you're, and the hard one is Boyle's because it's the only one that's not direct. Normally, if something's going up, the other one is going up. If something's going down, the other one is going down. Boyle's is the only one that is not that way. Questions? Okay, ladies and gentlemen. So, we've got 23 minutes left to class. In Google Classroom, ladies and gentlemen. In Google Classroom, there is a Quizlet that you can do, ladies and gentlemen, that'll help you review for the test. Okay? Again, you can use it as a multiple choice. You can use it as flashcards. There are different ways you could play with the Quizlet. Here is the study guide or the review. Okay? Now, up at the top here, ladies and gentlemen, are our topics. Now, all our topics basically deal with gas laws. Okay? We talked about air. We talked about what it's made up of. We talked about the pressure that it creates around us. For relationships, again, it wouldn't surprise me if I give you a picture of a graph and say, is this constant? Is this non-constant? Is this direct? Is this inverse? Or I may say, what would a graph look like that is direct and constant? Well, direct means the line would be going how? Up. Constant means it would be a straight line. So in 2 words, you could describe a direct constant relationship. Maybe 3. Going up and straight. That's all you have to do. If it's an inverse relationship, it's going down. If it's a non-constant, it is a curved line. Okay? Temperature. Remember the definition. Remember absolute zero and remember kinetic energy. The definition of temperature is the average kinetic energy. The only way to make temperature go up is to make the particles move faster. We cannot make them heavier. We can only make them move faster. So temperature is directly related to how fast the particles are moving. Temperature goes up, the particles move faster. Temperature goes down, the particles move slower. Okay? Absolute zero, the lowest temperature possible. Absolute zero measured in Kelvin, which we have to convert all of our temperatures in if we were to work gas laws. KMT, ladies and gentlemen, kinetic molecular theory. All matter is made up of tiny particles and they are constantly in motion. But remember, our definition of pressure comes from KMT. How often the particles of the gas hit the walls of the container. That is what pressure is for a gas. How often they hit the walls of the container. How can we change how often they hit the walls? We can adjust the volume, we can adjust the temperature, we can adjust the amount of gas. All three of those can affect pressure, okay? Because temperature was up here, ladies and gentlemen, these are our other three variables: pressure, volume, and amount of gas. I would know the definition of each. Okay, pressure, the bombardment of particles on the walls of the container. Volume, the amount of space something takes up. Amount of gas, how many particles are there. Know the units: millimeters of mercury, kPa, liters, moles. That table that I gave you on the bottom of the first quiz, where you had to match the unit with what it measures, wouldn't surprise me to see something like that on your test. Okay? And then, ladies and gentlemen, the gas laws. The 5 gas laws that we have discussed. These 4 and combined, all will be on your test with problems just like we have been doing. Questions, ladies and gentlemen? On your test, I don't know how many questions there are off the top of my head, but there are 57 points on your test, and it will be graded out of 50. That means you can get 7 points off and still get 100%. There is a bonus question, but there are also more points available than I am grading the test out of. That means there are 7 points of extra credit on your test. So you could literally earn 114% on your test if you get every question correct. So down below, ladies and gentlemen, is the review for the unit. Okay, you've got about 20 minutes, 18 minutes. Now, I realize you don't have the capability to draw a line here, ladies and gentlemen. So again, describe the graph of a direct and a constant relationship. Describe the graph of an inverse and a non-constant relationship. Fill in the table below. What does a direct or an inverse relationship look like mathematically? What's happening to the variables? And a gas law example. We defined pressure mathematically, and we defined it by KMT. Give me both definitions and list the 2 factors that will affect pressure mathematically. Give me the 3 variables that will affect pressure in KMT. Complete the table. What gas law? What are the variables? What are the constants? And then more problems like you have been practicing, ladies and gentlemen. Again, I'm not collecting this, but here's what I will tell you. If you have your periodic table and your solubility chart out and you cannot answer something on here, you better look it up and put it onto your chart. Because obviously it's something that I'm probably going to ask you on your test, and it's something that you do not know. So correct that, ladies and gentlemen. Questions? You've got the last 15, 16, 17 minutes here, ladies and gentlemen. If for some reason you have not yet turned in that mini lab, the gas laws, get it done and turn it in. Okay? You do not need to turn in this. Okay? And if you've already turned in the homework, I've graded it. If you haven't turned it in, you can turn it in if you want. I will mark it as turned in. Your choice. Okay? It's not going to affect your grade. It's not going to make it go up or down, other than it may help you prepare for your test. Questions, ladies and gentlemen? Awesome.